How is it going? Good morning. Local time in Mexico time. Good afternoon to you who are with us. Morocco time. And well, taking advantage of this space of this Congress, this 6th Congress, I'm going to talk to you a little about what is the project that Dr. Rafael Guzman, Dr. Angelica Hernandez, and yours truly, Oscar Cesar Cajina Malagon, are working on, which is about Mexican Sign Language translators. Let's start first about ourselves, about us. Well, we are from Mexico, from the state of Guanajuato. To be more precise, we belong to the State University of the state of Guanajuato in the Division of Sciences and Engineering. Well, we're talking about communication, about language. But what is language? Language is going to be the means by which we as humans access the world. It allows us to relate, share experiences, share ideas, make this exchange of thoughts, even modify ourselves by the environment in which we live. Many times the part of the language is seen, well, a little bit complicated, or we exclude a certain sector of society, well, because it is often complicated to establish that standardization, or that path by which we can reach a good understanding with other people, which is through language. But what is sign language, or sign language, sorry? Mexican Sign Language is a communication system, visual and gestural medium, which is used by deaf people, in this case for Mexico. It is a natural language that, like any language, has its own grammar, its own syntax, its own vocabulary, and well, let's land it in 3 characteristics. The first, facial expressions, hand movements, arm movements, or any part of the body. This includes gestures and various types of dreams. Something that characterizes Mexican Sign Language as well, number 3, is ideograms and datylology. Let's see, a little before moving on to more technical details, what these 2 concepts, these 2 characteristics consist of. In an ideogram, Mexican Sign Language is a word that is represented by different configurations of the hand. This is also known as words and is part of this gestural system. Here we can see it, represented by this GIF, which says, "Thank you, thank you." That would be what the ideogram is. Now let's see what the datylological part is, or the datylology. Well, unlike the ideogram, in datylology, through the movement of the hands, a letter of the alphabet is represented, which would be the grammatical part of Mexican Sign Language. Now that these 2 concepts have landed, which are going to be key to the next thing, we continue. As before, to close the introductory part, language, which allows us to communicate, allows us to be socially included and share ideas. In Mexico, a study was carried out, the INEGI, which is the body in charge of conducting censuses every 5 years, in Mexico, in the 2020 study, states that 5.7 million people have a type of disability, and approximately of those 5.7 million, 12.1%, represented by 692,000 individuals, begin to lose the hearing part. That is, the part of the ear, or they lack that sense. For this, well, Dr. Guzman, Dr. Angelica, and yours truly, we set out to create a translator, a tool that allows the inclusion of deaf people. We started by proposing that it be from text to Mexican Sign Language and from Mexican Sign Language to text, thus allowing a little more inclusion of this sector, sometimes forgotten. Well, here we have worked based on 4 prototypes, based on ideograms and dactylology. Prototype 1 is quite simple, which consists of an interface made in TechKinter, in Python, in which, well, at the beginning the variables are initialized and by means of a text box, I'm going to show them below. It allows the user to enter a word for later processing. This word is divided into letters and the letters are searched in the database, where the alphabet dictionary is, and finally it is represented in a dactylological way, by means of the alphabet. And well, if a text or a word is not entered as such, then the system is open to waiting. We can see it in the next slide that I'm showing you. It's a pretty simple interface. It's a text box, to which, well, we have the translation window, the text box, and the translate button. Once the user enters a word, a phrase, well, the result is the following. We can see it there. Prototype 1, hello, hi, hello, and we have the representation by the dactylological system. The second prototype that was made, this one was based on ideograms. Remember that ideograms represent words, and these are through gestures. A characteristic, an observation made to us by a person who advises us in this part, who is an expert in Mexican Sign Language. She told us the dactylological system is fine, but it happens that Mexican Sign Language has an area of improvement, which is that not all deaf people know the dactylological system, not everyone has it, it is not like standardized, so the recommendation here, which this expert in sign language made to us, was to add something that has movement, so that is where we enter prototype 2, which was made by means of GIFs, representing ideograms. The function is very similar to the previous prototype. The only thing that is going to change here is that instead of a dactylological system, it is going to go to a GIF. The flow of the program is very similar. Starting the variable, here we add the enter button as an improvement. The person arrives, types the word, we have a repository, a dictionary, with some phrases that were collected. It is searched in that program that is stored, where our dictionary is, and then the phrase is shown by means of a GIF, an animated GIF. Otherwise, if you enter text, if you offer us an enter or something, the interface is waiting. And we can see it below. There we have the window. It's very similar to the previous one. We have the translate button. And well, here we add the enter function. A simple detail, but I think quite nice. Here we can already see it. The last step of the work cycle is when it shows it, that we can see it. There is the GIF, the user types the word hello, and finally shows it to us through an animated GIF. I'm going to show you this next video. It's a bit fast, but I hope you understand. Hello. Hi. Hi. How are you? I'm fine. I'm bad. I feel bad. For the development of Prototype 3, here we continue to base ourselves as a test on the dactylology part, but this time using the vision system of the flow through computer vision. Here the part of the GIFs was added, completely modified, to make the monitoring more visual, in real time, and to that we added the PyTeX3 library, which allows us to read the statement, or the letter, or the word, that is being represented to us by means of the sign. Here I want to make an incense. As a background, there are many advances, but many of them are through dactylology. So, here when we have in Mexico, as an area of opportunity, which is not a totally standardized system, the recommendation that is made is to use the ideogram system more. But as a beginning, as an example, and as an experiment, we based ourselves on the dactylological system, and little by little we changed tools. For the system, the coordinates, here we do not yet resort to the use of TensorFlow. Everything was done by looking for the Euclidean distance of each coordinate, of each point, of each sheet of the hand. And the audio part was added, which reads part of the letter that is detecting. In this case, there are 3 vowels, the letter A, the letter E, and the letter I, which are later shown in different colors and are read. The voice synthesizer features a delay, with a delay of approximately 2 seconds. We have the program or program flow. Again, all the tools are initialized. The main libraries, in this case we use Pix3 and the MediaPipe library, being the Manus model, which was used for this prototype.
Letra A. Letra E. Letra I. Letra E. Letra A. Letra I. Letra E.
Within the result obtained, having taken the distances by Euclidean means, it is a little complicated. We see that later in the development of Prototype 4. Prototype 4. The flow of the program, this consists of 2 codes. The first code takes the captures and generates a dataset. It takes a sequence for each word. Hello, hello, thank you, how are you? How are you? Take a sequence of 30 videos, and each video consists of 30 frames per word. This is automatically stored in a folder. The samples are generated in an automatic folder called a set. Each sample is saved with the ending NPY. At the end, later, all these samples are saved in H5 format. In the next one, in the second program, which is where the H5 format that contains the samples is loaded and the training of the network that prepares the recognition is generated, for this we use a small short-term memory network with the samples that were made. The program is loaded, the samples are loaded, and this is where we start to make the movements by means of ideograms, no longer by means of dactylology, by means of the letters of the alphabet, but by means of ideograms and by means of phrases. The neural network, I tell you, is a simple model. It is short, long, short-term, and here is improvement, to make an improvement through the hardware, to have a camera of better resolution and the level of reliability, the level of tracking, I would quote it at approximately 7%, 7 of qualification, more or less. Here, likewise, following the same line of the previous prototype, of prototype 3, a subtitle is generated that appears in color and a voice synthesizer is also added. I'm going to show you below what the result obtained was. It has a slight delay, as we say there about the programming, but it is already part of what was obtained.
Bien. ¿Cómo estás? Gracias. Hola. Bien. Hola. Bien. Gracias. Yo. ¿Cómo estás? Yo. Bien. Yo.
Well, this was part of the results that were obtained. But hey, it's subject to improvement. There are only about 5 sentences that were recorded, and it is open to, through videos, continue to feed the neural network and obviously make it a little more reliable and more accurate. Well, our purpose for improvement is 1. To expand the dictionary, adding phrases, idioms, feeding it through recordings and using OpenCV, MediaPay's OpenCV library, integrate natural language libraries, to promote comprehension and improve translation, implement that it is not only text to ideograms or speech, but also, through voice, it is translated through an avatar. The development of a mobile application that is friendly to users, the automatic upload and translation of videos, and the addition of augmented reality elements. Our conclusion, the use of this interface, the application and development of this interface, we seek to raise awareness and promote the inclusion of deaf people, in this case, artificial intelligence technological tools at the service of a sector of society, using OpenCV, machine learning, and different types of platforms that allow improving and feeding what is Mexican Sign Language. All this through an animated avatar. Thank you very much for your time. Our contacts remain there, the contact of Dr. Guzman, the contact of Dr. Angelica, and yours truly, Cesar Malagon. Thank you very much for your attention.